Pretend my head is the sun and my fist is the earth. The earth is slowly moving around the sun. It takes about a year, exactly a year. The earth is going around the sun in this motion, and the chandrayaan is going in the same direction. Now, as I spin around here, it's really easy for me to maintain that orbit. In fact, it really wants to pull away from me. They call it a gravity assist. It should really be called an orbital kinetic energy assist. So they're taking some kinetic energy, not very much, from the Earth. With the Apollo missions, the capsule would take 1 or 2 orbits around the Earth, and then they would use a brute force burn to get it out to the lunar orbit. With Chandrayaan, they took their time. And during that time, they did a series of 5 thruster burns or orbit raising maneuvers while the vehicle was close to the Earth, each of which had the effect of raising the orbit of Chandrayaan. On the 6th thruster burn, they left the Earth's orbit and entered a lunar transfer trajectory. It's sort of comparable to a swing set. Remember when you were a kid, you'd have somebody pushing you on the swing, and they could give you just little pushes, and eventually you'll get really high. The way the Apollo mission does it is they do basically underdogs. You go run and you just brute force it up into the high orbit, and then the lunar transition, and then quickly lower it into lunar orbit. That method uses a lot of fuel. Over several weeks, they would have the Chandrayaan vehicle orbiting the Earth, and in the meantime, the Earth is going around the sun. And so what happens there, you're actually able to steal some orbital kinetic energy from the Earth. And this is similar to the method that they've used with the Pioneer and Voyager spacecraft. They would do these slingshots off of Jupiter and off of Saturn. It's actually the orbital kinetic energy of that planet that is causing the spacecraft to accelerate. Ooh. Hi, Robin. And again, this is sometimes called a gravity assist. I don't like that term because gravity is only the string that's holding the two together. It's not really the gravity that is doing the work. It's the kinetic energy of the Earth and of the moon. Just as if you were a skier, you wouldn't say that the rope is pulling you. The rope is just what binds you to the ski boat. The ski boat is actually what is donating kinetic energy to the skier. And if the ski boat takes a turn, you can actually make the skier overtake the boat because it's donated so much kinetic energy going this way. Whips it around. As I spin around here, I'm pulling it along, whipping it along here, and adding to its spin by going this direction. So how do they lower the orbit without having to do a lot of burning? They orbit in the opposite direction, and watch what happens. So now my head is, oh boy, I'm dizzy. Now my head is the Earth, my fist is the moon. Let's try this again. So orbiting in the opposite direction, and as I spin this way, it almost immediately starts lowering its orbit around my moon fist. So again, back to the sun, my head is the sun, this is the Earth. When I'm going this way, the same direction, it's trying to pull away. The string, there, in fact it did pull away. Woo! Oh, I'm dizzy. And again, when they're orbiting the moon, they go in the opposite direction. Here's the moon, and it just wants to immediately lower its orbit. Look how quickly it wants to go down. So they steal a little bit of kinetic energy from the Earth in its orbit around the sun, and they donate a little bit of kinetic energy to the moon in its orbit around the Earth. I know what you're thinking. Are we eventually going to slow down the Earth's orbit around the sun? Well, to accelerate a 4,000 kilogram object to escape velocity represents the same fractional amount of the Earth's total kinetic energy around the sun as removing 1 drop of water from all of the oceans in all of the world. It would take a lot of launches and a lot of drops to significantly affect either one of those. The numbers are large, but the math is actually pretty simple. But check me on that. I'd like to know what you come up with. Frankly, I'm more worried about these stray booster rockets that they discard as they're orbiting the moon. They separate this capsule. So this part is the booster. They still have to burn some fuel to lower the orbit, but they discard this. This continues to orbit the moon. They fire the rockets in the opposite direction and then slowly lower it to the surface. So there's a quick and easy experiment you can do at home or in your science class to show how orbit raising and orbit lowering maneuvers are done. Thank you for watching.